Hello, everyone. Welcome to our next webinar in the Gen AI webinar series. Thank you so much for actively registering and participating in our webinar series. This is Sindhu Priya, Senior Manager for Marketing at Amidus Technologies. As I say that, let me welcome back the speakers for today. Madhu, our founder and CEO, and Raksha John Ruskin from our Gen AI Excellence team. Hello, speakers.
Hi there,
Hi.
Sindhu. Thank you.
Thank you.
Hi, Raksha. Hi, Raksha. So, thank you for joining back. This webinar is a sequel to our earlier webinar on decoding GenAI cost structures. And today's topic is context engineering, reducing GenAI costs. So, let me get into the agenda, followed by a quick recap on the previous session. So, the last webinar we had was on decoding Gen AI cost structures. We briefly covered on what are all the fundamentals behind the costs, the Gen AI costs, the basic concepts, the token economics, what are all the cost drivers that could easily drain your Gen AI budget, like the context window, the hallucinations, and all those significant budget drainers. We also touched upon the models, the different popular models available in the industry, how to select the right model for your business use case. Our speakers cover all that. I will be dropping the previous webinar session link in the comment box soon, so you can have a look at it later. So as I said that today's webinar is going to cover the context, we are going to cover the context engineering in detail. What role, what, how, and the ways to do the context engineering better. The risk of not doing context engineering, skipping, and what are all the benefits of doing the same. And our speaker Raksha will also tell you the 5 context engineering levers that could help you do the context engineering right and save your Gen AI budget. She'll also walk you through the detailed process of RAG and semantic caching, one of the important strategies, key strategies in saving your Gen AI costs. So that's a quick walkthrough on the agenda. So let me hand over the session to Madhu to start with the context engineering basics. Hi, Madhu.
Hi. Okay. Thank you, Sindhu. Thanks, everyone, and welcome to all of them. I don't know which part of the world you're joining in now, with all the travel disruptions going on, which is very unfortunate. But I'm sure you guys are joining in from different parts of the world. And I'm here in India now in my own campus, so that's a great boost for me to do my session from my own office. Okay. Why I said that is the context engineering matters to how do we make a large language model act for us or do work for us. And as Sindhu mentioned, we talked about prompting, we talked about tokens, we talked about models and everything. So today, I thought maybe I'll walk you through the listeners over the next 3 to 5 minutes how the context engineering works. And before I hand it over to Raksha, I'll talk about a little bit of experiences we had in defining some of our agents. Okay, so let me also latch on to one of the definitions I think I like best now from Gartner. So it's there, which I'm not reading every word of it, but in a nutshell, when you use any generative large language models, you're you have to focus on how to make that AI systems understand you with the prompting, of course, but then keep some memory and understand it better by doing it. What's the intent of your questions? So, how do you create a context or an environment which allows the models to understand your intent and better make decisions, provided it is contextual, it has an aligned outcome from the enterprise. So Gartner, if I read it, it says designing and structuring the relevant data, workflows, and environment. So AI systems can understand intent, make better decisions, and deliver exactly contextual, enterprise aligned outcomes without relying on manual prompts again and again and again. So this engineering, once you do prompting, once you do that, then an engineer where you may be from the audience, you could be a business leader, you could be a programming person, you could be a line of business person, depending on which model and which work you're doing, you need to keep all these things into context. Within that, I thought, let's bring it down the context into four basic layers. And I'm glad we put the retrieval and grounding layer at the bottom, which we talked about. How do you do prompt? How do you do retrieve data? How do you ground yourself? Then comes this important element of how do you make the models manage the memory, which is relatively not the pure human neural network memory, but more of, hey, I asked you this question and model responded this way. You responded earlier, I liked it. So it is more of controlling what persists in that memory layer. Don't persist everything. So you retrieve it, ground the model, get the data sets, make the memory manageable. So you're doing a little bit of context engineering there. Then the question of, when we run the models, the most important question everybody has is ethical grounds and policies and guardrails. So you have to ensure that the model responds and it tries to remove the, guardrail issues coming out, which is the allowed controls, which comes under this policy and permissions. And at the top layer is more of your context refresh, because you keep the intent, then you continuously refresh the intent. So fundamentally, to do an extremely practical, useful context engineering, start with prompting with either retrieval and grounding rules. Try to manage the memory of the previous question, next question, yesterday, today, and your own little bit of dual tuning. Manage the policies and then refresh the context of all the time. So once you start doing it, once you start working on it, it's fairly easy, but you have to be intuitive. At certain times you will tune the model better. So that way, instead of just prompting and getting an answer, you create a knowledge context engineering layer at the enterprise level. Yeah, okay. So those are the four fundamentals. If you keep it, it's fairly easy, fairly intuitive. You always think that when I'm doing context engineering, hey, am I taking care of retrieval? Am I taking care of memory, policy, and context refresh? Okay. With that, I felt let me go to the next section of our topic. Because if context engineering is so easy, so logical, generally people ask, or wherever I go, the logical question is, if it is so powerful, why don't you give gen models everything? That's where you need to be prudent. You can't, I use the word naively dumping, you can't give everything and anything to the model within the context window and whatever limitations and start looking for answers, because ultimately these are all translator models, whether it is BERT or GPT, whatever, whether it is encoder logic or the translator logic. The more data you dump, the more things into database into a prompt, you may be degrading result too, because you may be slightly confusing what I call the third party model. So not only it can reduce the results, it could be very expensive, because every tokens on a closed weighted model, or when you do even open weighted on your own GPU cost, everything can be a trade-off. So fundamentally, even though context needs, retrieval, grounding, memory, policies and guidelines, as well as the final refresh, even though you have four layers in I call it in context engineering, you can't keep flooding all the layers. that will reduce in a way that it can become a latency issue. It could be a limits on the context window, but the later models like Claude and all giving enormous amount of window length. So you should be fine there. But more and more, I personally think you should be worried about the noise, a little bit of distraction, because you may start giving more data sets thinking that it will help, but it may be poisoning the context. You know, the word poisoning, it's more of you created a great context, great memory layer, but you start flooding it, then it may not know where to focus. So that way, put the context, even though it's powerful, use it prudently. And the last part always comes up because scalability and cost at an enterprise scale, when you do a proof of concept as an MVP, you may have a much better controlled context. But when you start scaling it at the enterprise level, the difference in deployments could be even economically unsustainable. There are a lot of reports. I'm not saying the adoption of generative algorithms in enterprise is just because of cost. It has many other elements to it. But if you cover the context engineering well, right from the 4 layers, I'm not overloading every element of it. I think at an enterprise level, most models for a persona, different types of models, different types of work could be a really a winner. Okay. So context is powerful for the audience, as I said. You may be facing it every day, when you are using it, because adoption of GenAI has been increasing it. I'm sure whoever is listening in, you're doing it. But try to ensure that, your own context, what you create and the memory you create for the model. Sometimes I say, if you create a very good context and memory, you're actually creating a digital twin, so that you're making the model understand you, making the model understand what you're asking, why you're asking as a persona. So it will respond really good. And that persona or that enterprise context layer can be a digital twin of yours. Okay. With that, Sindhu, why don't I go to the next one? Now comes this where the fundamental shift we have to build with our LLMs. So when you look at the context engineering, when you see that all models, whatever sections you give, it becomes capable, it grows, and that's where we call it as the compacting the content. So I'm actually using a little bit of terminologies. It's a little bit confusing, but it is not. You create this entire fundamental way of using LLMs in a way that it should, react to your needs properly, and try to have this attention budget at each step. Just not expand every element of it. So whether you're compacting it or you're designing a token efficient tool or enabling just in time, the principle is the same. You should always use the right context, smallest set of high token signal that will give you the maximum probability of the desired results. Because LLMs fundamentally are probabilistic equations. The way you tokenize it, the way you vectorize it, the way you have the embeddings. So as long as within the context, within the memory, you try to create a high signal token which will give you the most probabilistic answer, context engineering in an enterprise level will be a sure shot winner. This is the only area where, when people are implementing LLMs, or when we did in a couple of places, we are having a next session where we are talking only on the agent we did. The learnings are, it's a continuous evolving learnings. Create a little bit of shift in the way we operate. That's exactly where we are bringing it here. You create a smallest set of high signal tokens, which will give you the probability of the desired outcome. Okay. With that, Sindhu, shall we go to the next slide? And this, I think, this is an area where Raksha can talk to you all. She will take it up and go from there. So I'll be online. I'll be listening to. If any of you users have any questions, please text us. And Raksha, all yours.
Thank you,
Thank you,
Madhu.
sir.
Please,
Thank
Raksha.
you, sir, for okay, sure, ma'am. Thank you, ma'am. Thank you, sir, for your detailed explanation about context engineering. So, from Madhu sir's speech, you could find that the model organization have been paying a lot for lot because of context, not knowing that how to handle the context. So they were paying because they were not unable to know how the context are costing much more. So in this slide, we are going to see the 5 context levers that can cut entirely your 30 to 60% of your cost. So, and then the first one is selective context retrieval, that is RAG optimization. So the core idea behind this is reduce input token volume before retrieval reaches the model. So what happens within the RAG optimization is instead of passing an entire document, that means if the token of entire document will be 50K or much more. So the in next slide we will telling you how the RAG will be performed. So in this I am going to explain a little bit about RAG. So the full document token might be 20,000 tokens, but when the RAG taken the tokens, it will be around 2,000 tokens, which makes reduce the 90% of cost of your entire model. This is and the second lever is semantic caching. So this is different, much more different than traditional caching. So the example I want to tell you is if you have given a prompt to your system that what are your business or but previously the answers were stored in your semantic cache memory or in a vector database. So what will the model do is just compare the prompt you have provided within to the vector DB. It doesn't call you LLM. So entirely the 30% or more than 30% of the cost will be reduced because the tokens were not given to the LLM. This is one of the main advantages of semantic caching. And this semantic caching works better on frequently asked questions, chatbots, and policy query chatbots. And and the next third lever is prompt compression. So instead of asking, please kindly explain in a very detailed and elaborate manner to your chatbot, you could ask the summarize it in 3 bullet points. It is an efficient way to reduce the number of prompts within to the LLM. So, and the fourth lever is context catching. So context catching is consider a situation that if a developer want to review their PR, so the entire token might be 10,000 K token, and in every time the LLM have to check into the entire tokens of data. But through context catching, just if you're creating a PR review for a code base, it will just embed the details in the vector manner within the cache memory. So you just it will just verify the changes in the code base, and the changes will be in about 3,000 tokens or less than that. So you might reduce a massive amount of tokens through context catching. So context catching can be recently found in Gemini models. So the price calculation for Gemini context catching I explained it in previous webinar too. The cost structure is how the calculation is. For 1 million token, we have to pay $1 for per hour. So if you are not using using this context catching in 1 hour, you should not you didn't want to pay it for that hour. So it might reduce lots of spending for the LLM. And the final one is model routing. So you might not use you should not use a high-tech model like Claude Opus for a simple question which can be answered by GPT for 4.0 mini. So you have to if you want to ask the like hi message or something else, you want to simple messages like what is your climate today, it is a simple answers which can be answered by the mini models like the GPT 4.0. You for the for high tech mod for high tech purposes you could use high tech model. Through that we could reduce lots of cost. So model routing is something which if the user was asking us a little question, that is a very small questions that GPT 4.0 can reply. So the model just put the prompt into the GPT 4.0 model. So and for summarization we could use a mid-tier model for summarization purpose. And for high-end code-based checking, we surely we have to use very higher model like Pro versions, Gemini 5 Pro versions, Gemini 3 4 versions are Cloud Opus LLMs. And with this, I have to explain how this RAG optimization is performed. And as you see in this diagram, first, through prompt, we will be giving the document to the to the LLM. So before it enter into the LLM, the data will be chunked and embedded through embedded models, and it will be stored in the vector DB. And when the user asks the questions, the prompt itself can be converted into embeddeds. You might have a doubt that whether it prompt to got chunked or not, but prompt is very little, very small content which might not need chunking. So it will be embedded and will be sent into the vector database. So through in vector database, the database will check the similarity of contents. So if your if your health policy has a lot of details, and if you want to ask about hospitalization bills, you won't check entire document, right? You just want to know what is the cost of a hospitalization bills. So the prompt will be checking the hospitalization bills and will take that that amount of details and will take the similar chunks will be taken, and the chunks along with the prompt will be sent to LLM, and the LLM will be generating response. So the tokens of entire document will be 50,000 K, but the chunks will be 2,000 K, and which will reduce enormously and drastically your cost will be reduced. So this is the functioning of RAG optimization. And I want to tell how the semantic catching works. So semantic catching is nothing but the semantic that the semantics mean meanings. Exact meaning of the content prompt have been checked through the from the vector DB. So here your previous chat history will be stored in the database or vector DB or a cache memory. So the prompt will be embedded and will be sent to the vector DB, where approximately ANN network, that is approximately nearer neighbor algorithm will be applied. So where the semantic similarities will be checked. So the threshold will be set by the user or the developer who want how much similar words should be chosen by the model. If the semantic similarity value is greater than the threshold value, it will return the exact answer which was stored in the vector DB. And if the answer, if the threshold, if it is less than the threshold value, and it will return the prompt to the LLM where the user will get the response, and this question as well as response will be stored in the previous set as possible. So finally, I want to tell that when these five levers are implemented together, RAG reduces input volume, semantic catching eliminates duplicate calls, and prompt compression reduces token load, context catching prevents reprocessing, and model routing prevents overuse of premium orders. So from this, I just want to conclude my session. I'll be here. If you have any doubts, you could ask through the chat box. Thank you. Thank you for the opportunity.
Thank you, Raksha. Thank you so much for walking us through the five important levers that could help us, help the listeners, and help the practitioners to save a lot. The semantic caching and drag optimization is key today for all of us to utilize and make the effective get the effective results. So far we haven't received any questions, I think it's time for us to close. Please, listeners, do post all your questions or any queries that you have related to Gen AI, the strategies or the ways to reduce the cost optimization, FinOps part of it, everything, write to us. We are available on LinkedIn, Twitter, and we are actively engaged on all the social media platforms. You could reach us through our mail, info@familysglobal.com as well. So with that said, it's time for us to close. Madhu and Raksha, would you like to say anything before we close to the audience?
Yeah, thank you, Sindhu. I think it was a great session. I'm glad we could talk about context engineering. But when I heard Raksha talking, yeah, I've been hearing it for many times, I made it sound context engineering look simple, but she made it the real trouble. I think audience should have felt it. It's a very intuitive way of doing context engineering, and the options that Raksha gave were phenomenal. Fantastic. Thank you, Raksha. Thank you, Sindhu.
Thank you, sir.
Thank you, speakers. Make use of all the strategies we have shared. Our next webinar is we'll be sharing our own experience. We have developed our own FinOps agent and Blue, the lessons that we learned from scratch. That's what we are going to share in our next webinar, and it is scheduled for 25th of this March. Our registration links will be shared soon. Follow us on our social media pages. Thank you so much. We'll catch up in our next session. Thank you.
Thank you.
Thank you.